Hi guys, welcome. Today is the penultimate episode of our ESS series where we're going to be looking at topic 7, so climate change and energy production. So we're going to start by looking at the different resources available to societies and then discuss climate change, which is arguably the most talked about issue regarding the environment. So to begin with, there are a range of different resources available for societies to use, and we can broadly distinguish them into renewable and non-renewable resources. And what really makes them different is their sustainability. So renewable resources are things like solar energy, wind energy, that we can use in a way that doesn't deplenish the stock. So we're living off of the interest of the natural income that we take from the natural capital. Non-renewable resources, on the other hand, are things like fossil fuels that we are unable to use sustainably because they take such a long time to replenish. So we are inevitably going into the stock if we use them, and it's impossible to live off of the income. So when we think about the reasons that a nation would choose to use a renewable or a non-renewable resource over the other, it does tie in with political matters, such as whether it's an MEDC or an LEDC. So as you can see from this graph, MEDCs typically consume much more energy compared to LEDCs, partly because they have the technology available to do so. So this isn't really possible in LEDCs. And similarly, they will have less technology available for renewable energy resources. So think about the amount of money that it would take and kind of in the vast amount that we need for solar panels, for wind energy technology. So both of those are things to consider. So the IB want you to be able to evaluate the use of a non-renewable resource and a renewable resource. So starting with coal, which is an example of a fossil fuel, the advantages are that at the moment it's in plentiful supply. It's easy to transport as a solid, and it's relatively cheap to mine at the moment as the infrastructure is built around it. So this is kind of a very common resource to use at the moment. The disadvantages is that, first of all, it's non-renewable. So as we mentioned earlier, we can't use it at a rate that doesn't deplenish the stock. So we are going to run out of it eventually. Secondly, burning coal releases carbon dioxide, which, as we'll come to see, is a very potent greenhouse gas that contributes to climate change. Secondly, the sulfur content contributes to acid deposition, as we saw in topic 6. And the soot particles contribute to smog. So you can see that it's involved in acid deposition, climate change, and tropospheric ozone, which are 3 big problems regarding the environment. Evaluating a renewable resource such as wind energy, the advantages are that unlike most non-renewable resources, it doesn't release any pollutants. So it doesn't contribute to the greenhouse effect, acid deposition, anything like that. And it's sustainable, so it won't run out, and it's clean energy that we're able to freely use. It also leads to a smaller ecological footprint, which we will define later on. So these are all the great things about a renewable resource. However, it is unreliable. So you need to build it around places that have good wind, and it's kind of it relies on the weather. There have also been reports of icefall and being thrown from the wind turbines as well. And some people argue that it is unsightly, so people wouldn't want to live near them. However, in my opinion, I think the advantages far outweigh the disadvantages, but that's just my opinion. All the IB wanting to be able to do is say the good things and the bad things about both a renewable and non-renewable resource. So then let's consider the factors that influence energy choices, so that influence whether we would rely on renewable versus non-renewable resources. First, availability. So right now, yes, coal is in plentiful supply and the infrastructure is built around it. So it would make sense, I guess, to rely on coal at the moment. However, things like wind energy and solar energy have unlimited availability. So as things progress and coal eventually runs out, I can imagine that we will turn to renewable resources more. This connects to technological development. So as we've developed technology that's able to capture solar energy and capture wind energy and turn it into something kinetic or convert it to heat, before these were things that weren't available to us. So it makes sense that we had to rely on non-renewable resources. And that's kind of the case in LEDCs that don't have that technology in place yet. Also economic choices. So LADCs are more focused on development rather than investing money in these more clean energy sources, and similar cultural effects that link to that. And there's also environmental kind of awareness. So the more we become educated and aware of the impacts of non-renewable resources or the backlash following a disaster such as the nuclear reactor that blew up or Chernobyl, all these factors together influence a nation's and the overall world's reliance on one kind of resource over another. But future prospects, which I kind of hinted to earlier, are that non-renewable resources will inevitably run out. They are unrenewable, and their costs will increase as this overall stock deplenishes. So that's what scientists predict will happen. Environmental taxes will be made use of more by governments to kind of compensate for those effects. And renewables will eventually become the main source of energy. So we will have all the technologies in place. And yeah, these are the future prospects regarding energy choices. So the next thing I want to turn our attention to is the greenhouse gas effect. And the first thing I want to clear up is the common misconception that the greenhouse gas effect is a bad thing in and of itself, and it's not. In fact, climate change and slight global coolings and warmings have been a normal and necessary part of the Earth's history, and without it, we wouldn't be alive. So you can see in this graphical representation that there have been influxes and coolings in the Earth's history. The problem is that human activity has widely contributed to recent changes and caused a unbalancing of the natural equilibrium. So we've caused the Earth to warm much more than it ever has before. But just make sure that in your head it's clear that the greenhouse gas effect is not a bad thing by itself. And in fact, this is why it's good for us. So greenhouse gases are the ones that maintain global temperatures, and they do this by basically absorbing some of the energy that is re-radiated from the Earth. So they balance the heat that's moving in and out of the Earth in that way. So let's go over the natural process that typically happens. So high energy radiation comes in through the Earth and passes the gases, and some of that radiation is re-emitted back to the atmosphere. Now, the greenhouse gases provide an insulating layer. So some of that infrared radiation that the Earth re-emits is absorbed and kept in by the greenhouse gases, and that is how they heat up the Earth. So when we talk about global warming and the greenhouse effect, we're really meaning the enhanced greenhouse effect, which is the fact that through burning fossil fuels and releasing carbon dioxide at a really high rate, and through activities such as deforestation and over-reliance on inorganic fertilizers and landfills, we have contributed to the greenhouse effect at a rate that we've never seen before. So we're taking this natural process that's usually a good thing and good for us and keeps us alive into something that's having catastrophic effects. So all of these are raising average global temperatures. So the four gases that have the biggest impact when it comes to the greenhouse effect are carbon dioxide, water vapor, nitrogen oxides, which are released from internal combustion engines like in cars, and methane, the primary source of which is cattle. And as I mentioned a couple of slides ago, they absorb the long wavelength infrared radiation that's re-emitted from the Earth and consequently heat it up. So what are the effects of climate change? These include rise in sea level, a complete restructuring of biomes and their distribution. So there's a shift up in latitude, which can cause some species to go extinct, especially ones which aren't able to adapt as quickly, like plant species. There will also be, and there has been, damage to human health as there's an increase in the spread of tropical diseases. And it causes a change in weather patterns. So this image shows you the rise in sea level or melting of the ice caps problem. It's really sad. I hope that resonates. So the final thing I want to tell you guys about in this episode is how we can apply the systems approach to climate change. And yeah, as I mentioned in topic one, it's a very versatile concept that we can apply to such a range of different things, and climate change is no exception. So let's look at how we have feedback mechanisms at play, both positive feedback and negative feedback in climate change. So positive feedback, if you remember, is the one that causes change in a deviation from the equilibrium. So A rise in global temperature leads to permafrost thawing, where there's usually stored carbon dioxide and methane, which are both two of the four most potent greenhouse gases. And as they're released, they contribute to global warming, which causes more rise in temperatures, which causes more permafrost to thaw, and so on. So you can see how it's a self-fulfilling kind of cycle now. And the negative feedback mechanism then at play is evaporation. So as the surface temperature increases, it causes an increased evaporation rate from oceans, which means there are more clouds in the lower atmosphere, basically. Clouds have high albedo, so they're very reflective of light. And this decreases the surface temperature slightly, which decreases evaporation and means there are less clouds. So you can see that these are kind of effects to diminish the change. So they're negating the change that climate change caused to begin with. So I hope that makes it clear how we have both positive and negative feedback mechanisms at play in climate change, and that's how we connect the systems approach to this topic. Thank you so much for watching, guys. This is the penultimate episode, so I'll see you in episode 8 for the last episode of our series.